Hello, Tom from EverystepCalculus.com, EverystepPhysics.com. Calculus problem regarding local maximum and minimums in graphing a function. Index 8 to get to my menu. We're going to scroll down here to get to local max and min. You can use second and the cursor here to go screen by screen on your titanium. There's local max and min. We're going to find any one of these things that you want in there. We're going to enter our function. You have to push alpha before you enter anything in here, and the function is alpha x to the 5th minus 15 times x cubed. I always show you what you've entered. You can change it if you want. And you can scroll to any one of these things. I want to get maximum mins, so I'm going to scroll down here. And you can see that maximum and mins they don't explain it right in a lot of professors and stuff like that, but to me, the first derivative is the slope of a line, okay? And when you set it equal to 0, you're making that a horizontal line. And a horizontal line touches a maximum or minimum point only at one point. It does not cross the graph and touch 2 points. It's just one. So that's the theory behind it. You find the derivative of any function, set it equal to 0, solve for the x values for zeros. And you got another thing that bugs me is that they call these critical points. These are not critical points. These are critical numbers on the x-axis, -3, 0, and +3. Okay? They are not critical points. There's a difference. And when you set it at x equals -3 into the original function, you come up with 162, and this is a critical point. It's a point, x and y point, -3 and 162, okay? When you solve the other critical number, which is zeros, you get a critical point of 0, or a critical point of 0, yeah, 0, 0. At +3, when you put it into the original function, you get a -162. That's a critical point, 3 and -162. Now you notice that calculus, they want you to find the maximum or min. They want you to find use the second derivative test. So they want you to find the second derivative. Well, here it is, the second derivative of the function. First derivative is this, okay, and then you put the critical numbers into the second derivative, okay. And this is negative. If it's negative, the point is a maximum point. But notice that, to make it simple, notice that the y value is +162. So this has to be a maximum at 162. You have -3 for the x value, 1, 2, 3, and then all the way up for 162. So there has to be a maximum of this 162. But they want you to do the second derivative just to play games, I guess. And at 0, it's an inflection point. So you have the function going up here at 162 and coming down and going through the x equals 0 and y equals 0. At x equals 3, +3, you got 1, 2, 3, and then you go all the way down here to -162. Well, that's a minimum. All you have to do is look at what the negative or positive amount of the y value is here, and that'll tell you where it's a maximum or minimum. But they want you to do the second derivative test. And then notice how tough it is, because this is positive, so then therefore you have to remember that it's minimum. If this is positive, the second derivative test is positive, then this is minimum. It's usual calculus baloney, you know, that they do. And of course, pretty neat, huh? Every step calculus.com, go to my site, buy my programs, and pass your calculus. Get out of there. Don't ever see it again. It's worthless. Have a good one.